Hi everyone, today we will be learning about single displacement and the activity series. In grade 10, you learned the general pattern for single displacement reactions is AB plus C produces CB plus A. Looking at this general format, what kind of compound do you think AB and CB have to be? Are they ionic, metal and nonmetal, or are they molecular two nonmetals? Well, in order for us to be able to displace something and for a reaction to occur, the ions must be free to move. So it has to be an ionic compound reacting with a metal, if it's cation displaces cation, or an ionic compound with a halogen reacting with another halogen to displace your anion. Now, looking again at this general equation, AB plus C produces CB plus A, what kind of elements are C and A? And in this case, they have to be metals, okay? So again, in order for a reaction to occur, the ions must be free to move. Therefore, the ionic compound must be in aqueous state. We talked about this last year. Aqueous simply means it is dissolved in water. Remember that single elements are found in their elemental state. So let's practice this, and let's make sure we can include states. So let's write the balanced chemical equation for iron. Iron is a metal, it is a solid in its elemental state, plus mercury nitrate. This has to be aqueous, okay? What will happen for this reaction? Well, we are going to use the activity series of metal. So if you take a look on the back of your periodic table for your data sheet, you'll see this activity series. So anything at the top is the most reactive. Anything at the bottom is your least reactive metal. Okay, notice that you do have a hydrogen here. Hydrogen is a non-metal, but it does have special properties and it can displace some metals, okay? You'll also notice on the other side, you have an activity series for your halogens, okay? So either for your metals or for your halogens, you can use the activity series to predict if a reaction will occur. So in our case, we have iron, and we are trying to displace mercury. Iron is more reactive than mercury, so yes, this reaction will proceed. So I will displace my cation with my cation. So I will have iron 2 nitrate plus, let's add our states. So it'll be aqueous plus mercury. Mercury's elemental state is liquid. We write a cursive L for this. Another single displacement could also be written as xy plus z produces xz plus y. And in this case, we have our anions being displaced. Okay? So anions or nonmetals are being displaced. This is where you use the other activity series. How do we know if a reaction will take place? We need the metal activity series as shown to the right, which was determined by doing a series of reactions of metals and ionic solutions, like you will be doing in a lab tomorrow. When comparing any two elements, metal or halogen, the higher and more reactive element will displace an ion that appears below it. So just like I showed you, what you see on the back of the data table, if, for example, the metal is written higher than another metal, it will displace. However, if it is below the individual metal, it will not displace and no reaction will occur. Similarly, with your halogens, fluorine is the most reactive nonmetal, and therefore it will be the most reactive. It will displace all of the halogens. However, bromine can only displace the two below it, as an example. So let's go back to the note. You also will notice here I've provided you a bit more of a detailed activity series of metals, but it also goes from least to most reactive. This is for metals. We'll come back to using that later. So the metal activity series will always be provided on tests and quizzes. It's always on the back of your periodic table, which you get. Reminder, notice that hydrogen is in the series. And remember, hydrogen is a nonmetal, but it can displace metals. Okay, in single displacement reactions, consider one of the hydrogens acting in the same way as a metal in other aqueous solutions. So the same as a cation in an aqueous solution. Okay, so let's check. Will aluminum displace tin? Well, if aluminum is up here and tin is down here, aluminum is more reactive than tin, so yes, it will displace. What do you notice about the metals at the bottom of the activity series? Right here. Well, you notice that they all come from the middle of your periodic table, which is your transition metals. Okay, and on the next page, when you look at your halogens, right, here's your halogens activity series. Here it goes from least to most reactive. Again, this is for halogens. You will notice that these are all on one side of the periodic table. It's on the right side if you're looking at your periodic table, and those are your halogens. Okay, so let's do a little bit of application. Why do you think that copper is used for water pipes and not lead? Well, look at your activity series, okay? You find copper very low on the activity series, so it's not very reactive, okay? Whereas lead is more reactive than copper, okay? Another thing you have to remember, water is made up of hydrogen and oxygen, okay? So you're trying to see what will water react with. If we use lead will react with the hydrogen and water, and it will displace it. And you don't want a reaction occurring in your water pipes. So therefore, copper is used. Copper is below hydrogen. It's less reactive than hydrogen. Therefore, it is least likely to react. Okay? So copper is below hydrogen on activity series. Therefore, it is least likely to react with the hydrogen in water, which is H2O, right? That's where the hydrogen comes from. Okay, whereas lead would react. Lead would displace hydrogen, and we don't want that. Okay, now a note to add on, a more reactive metal will react with cold water, where less reactive metals require thermal energy or hot boiling water to react. You can use on the side, you'll see on this activity series, it tells you, for example, all of these will displace hydrogen from water, steam, or acids. If you look at the very bottom, you'll see that they do not, the least reactive, they do not displace hydrogen from water, steam, or acids. And then this kind of orange section displaces hydrogen from only acids. And this darker orange will displace hydrogen from steam or acids. So you'll see they're more and more reactive if they're higher up on the activity series of metals. Okay, so use that to complete the next couple of activities. Okay, check your answers, and I will see you in class tomorrow. Thanks so much.